Thank you for checking out my video today. We are going to be talking about laser welding safety, or laser safety kind of in general for the most part for what we're going to be doing. It's one of the topics that's mostly highly looked over. Everyone goes online, watches the videos. This is great. This is the best thing in the world. It's going to replace, how I'm welding things now. It's way faster. But one thing people don't realize is the safety concerns, the dangers, kind of the requirements. So we're going to be covering that today. And I'll be right back. Thank you. The IPG lightweld system is classified as a class 4 laser. That means by definition, I'm going to look in the ANSI book, a class 4 laser is a hazard to the eye or skin from the direct beam or may pose a fire hazard or diffuse reflection hazard. That is the direct description from the ANSI book, talking about lasers, why they're classified the way they are, how they can be used, and also covers all the safety requirements, what you need, how to figure out what you need, and all that piece in there. One of the requirements, because it is a class 4 laser, for control measures are required. It's not recommended, it's required. Training is required. You have to have safety training, you have to have laser operator training. An LSO, which is classified as a laser safety officer. That's required. You have to have an LSO on site with your facility. If you're going to have a class 4 laser, which an IPG handheld laser is a class 4. And engineering controls are required, not recommended. It is required to have engineered controls to contain the laser in a booth where you're going to be using it. That way everyone in the other vicinity or in the entire shop can be safe as well. As I mentioned a few minutes ago, the ANSI standard book. This is the book that OSHA uses to classify what's required for the job site for laser safety. It has all the controls, all the recommendations, beam widths, beam powers, how they're rated, how to know which ones you need to use for what application, what glasses you need to have for what you're doing. All the calculations are in there for how to be safe, or as safe as possible. They're like with a class 4 laser, you can put a class 4 laser in a class 1 environment, which means it's sealed away from everybody else. The only thing in the box it can be aimed at or kind of be used towards is the piece you want to be used on. That's why most, like robotic welding cells for laser, they're sealed. You put the part in there, you close it. If it's not closed, it won't turn on. That way there's no other exposure to anything other than in that box. So I said that would be a class 1 cell with a class 4 laser inside of it. So it's a containment device. There again, the engineered controlled containment device. For the handheld system, for truly handheld, you can't put it in a class 1 device because you're gonna have an operator in the same area with it. So there again, this book helps tell you what glasses your guys need to have, what safety gear he has to have. It talks about walls, the containments, the systems, interlocks, are they required or not required? The signage going outside the room, it's all in the book. And also the LSO training class, several of them that I've seen and been through, also use this as the guidebook. This is where the information is coming from. This is the standards that everything refers to. So if you're on the market to get a handheld laser system, whether it be from IPG or from anybody else, you need to do yourself the favor and get this book. Know the safety, know the requirements, know the potential hazards that you're putting your employees into. Even though most shops I'm going to replace my current TIG welding system with this laser welding system. So we're a welding shop, we know what we're doing. Yes, you're a welding shop, you know what you're doing. But the light hazard from TIG welding is much different than that from laser welding. When you're TIG welding, you're welding along, everything's going good. If you get an arc flash by some chance, it happens. Everyone gets arc flashed at some point in their career. It's a bad weekend. Your eyes burn. They feel like you got sand in them. It's just a terrible weekend. A few days later, you're good to go. You're back to work. Everything's ready to go. With laser application, if you get flashed, so if you get hit by the beam, which it'd be a major accident if it happened, you're blind forever. It burns your eyeball. It burns the retina. It tears things apart. It's a permanent injury. You're not coming back from it. So safety is a major concern. So let's start off with eye safety. The first thing we're going to look at here is laser safety eyewear. Here's one pair that I particularly like to use. It looks a lot like my sunglasses I wear. They're nice, they're lightweight, they're comfortable. As a fairly clear rating on the lenses, this is, let me look at the spec on here. This is, it's a 7, I know it's a 7, there it is. It's an OD7 at 1045 to 1064 nanometers. This handheld is rated for 1050. This is the good pair of glasses to wear for it. Most people see these and say, well, that's a really clear lens. How is that a laser safety glass with that clear of a lens? The lenses are also rated with another number. This is, I believe, a 75, so it's a fairly clear lens. The higher the number, the clearer the lens. And so for operator appeal, you want to go with the highest number you can, but still be within the rating of the glass you need to have for your application. So in order to get that, you need to go through the book, make sure it matches your determination. This is my laser, this is my application, this is how it's going to be used, so you're wearing the right eyewear. But the clearer the lens, the more likely that someone's actually going to wear it and keep them on and use them the way they're supposed to be used, as opposed to taking them off. So the next thing we're going to look at is the welding helmet. Yes, not your traditional welding helmet. This is your traditional welding helmet. This is added on for the laser safety piece of it. The plastic that the standard welding helmet shell is made out of melts fairly easily. For traditional welding, it's not super high intense, radiant light coming off of them, and we have seen shells melt from the plastic and everything else and kind of deform from getting too close to the heat. But with the laser application, if you get a reflective beam that comes straight back at the helmet, which happens more often than you might think, that beam has enough focused energy to basically drill a hole through the plastic and burn your face. If it goes the wrong spot, it can cause a lot of damage, and it's instant. It's not slowly getting hot, slowly melting, kind of getting there. The reflective beam can drill a hole, punch you in the face, kind of cause some damage very, very quickly. So that's why this shell is on here, to help with that energy. It will help absorb that energy. It'll hit this piece, start to get hot. It'll give you more time to react and realize something is going wrong. Something happened that should not be happening. They are designing a few new hoods, different shell materials than the plastic this one's made out of here. They should be released in the next few months, hopefully. I've seen one that was carbon fiber. It was really nice. It'll be nice, lightweight, better headgear design. There again, this helmet here, traditional welding helmet headgear, is not designed to have this much weight hanging off the front of it, so it makes the headgear not want to stay up. So it wants to fall down on your face all the time, which makes it uncomfortable. So a lot of effort has been made to make better welding helmets for laser application. And next we're going to talk about some containment devices. Okay, I have changed buildings over to where my laser actually is at, as opposed to the main welding lab. They're going to have it in a separate room with locked control access to the doors, so only people that are authorized to be in with the laser can come into here. It's a key-coded handle to come in, and then once you're in here, you're in a laser safe area. The door is marked on the outside, as well as once you come in, all the panels are marked. Danger, laser in use, class 4 laser. These panels are not plastic. They're not the regular material that you would see on a welding screen. This is a steel panel. It also has a dimple design to it, which helps with the reflective of the beam. In case it were to come off of something and hit this, it's going to be diffused better. It's going to disperse and not carry as much energy. So it just makes it a little bit safer. This is a hard anodized. It's not a paint or a powder coat. The reason why you want to go with a hard anodized as opposed to a paint or powder coat is fume. The laser can remove the paint. Everyone's seen like the laser cleaning. So they're going to, as it's cleaning off regular material, same thing can happen to this. If it was paint or powder coat, it would start to remove it. It would diffuse. It would kind of make a lot of smoky mess in the area, and you don't want that. You don't want to be breathing in all the extra fumes, everything else. So this is a hard anodized, so it's better for the heat, better for the control. It's also a low reflective. That way, it's not not like a mirror. It's not a polished stainless or an aluminum or something bright that the beam's going to reflect off of easily. It's going to hit, more absorb, and kind of diffuse, less come off the panel. One of the things that's kind of required for a laser safe booth or laser safe area is a sign. When you're in the booth, lasers in use or engaged or turned on, this sign right here is on, letting everybody know that's outside the booth that lasers in use. You're going to be doing some welding in there, and if they're going to be going in there, they also have to have on, the laser safe eyewear, laser safe safety gear, their gloves, their jacket. Just like with regular welding, any exposed skin will get burnt from the rays coming off of this thing. So you want to make sure you're protecting yourself as best you can. One other thing that they talk about as part of the LSO program is control systems. One way, easy way, is that little red deal right there. Red deal right there. It's an interlock for the door. If this door opens, the laser shuts off automatically. It will not turn back on until the door is closed and the air is reset. That is not the case on all laser systems. You can get a system that's not like this one, that has all the safety features built into it, that does not allow for that integration switch to be put into it. So you might have to create a circuit to be in as far as in that classification, or you can have a different engineered control system. You can have different door systems. You can have, instead of like mine is an open door that goes in the other room, which is my controlled area, you can have a smoke control containment inside of the booth itself that does not shut the laser off directly if your system doesn't allow for it. But it's engineer control. Your specific laser safety officer will make that determination. What is your laser? How does it work? How can things be wired into it? How can you make the safest environment for your application? There again, I'm just kind of going over some of the basic stuff, not making direct recommendations for you specifically. Your laser safety officer needs to make those recommendations. Look at your equipment, know what you have, how does your stuff work, and what does it allow for. Thank you. Okay, and I'm back here in the main welding lab, a little better lighting, easier to make the videos on. Laser safety containment for your area. There again, like I said before, your LSO or your laser safety officer needs to make all the recommendations as far as what your shop needs, what your area needs, what containment you need, what control devices you need. Can you build your own? Do you want to buy a system? We always recommend that you buy a system that's engineered for laser safety. But there again, you can go over the book, you can create your own standard, create your own controls. As a laser safety officer, you have the ability to make that decision for your facility. For when I sell laser systems, I recommend buy the system. It's engineered for your application. Everyone needs something a little bit different, a little bit custom. One of the companies I work with that designs and engineers systems, they do just that. They are been in laser safety since the mid-'80s. They know what they're talking about for laser safety requirements. They make custom cells, custom booths, curtain enclosures, windows. They can tell you what you need, how it can work. They can help make recommendations for what will fit your needs, your area best. If you currently have weld cells like the ones behind me, you can need a few things, change to those, and you could make it for a laser safe area. Not exactly with the curtain towers is there now, you have to have the interlocks and everything else. But if this was how your shop was set up currently, and you were to say, I'm gonna use lasers, I've made the decision, I like how it's gonna work, it's gonna be the good fit for me, it's gonna make me to where I can actually compete in the marketplace, that I am gonna go with lasers. They can help you design and engineer how to make your current area like mine. This is a regular weld lab, weld shop area. How you can make it laser safe so you can use these in the best way, best manner possible to keep your employees safe and healthy every day.